Thank you for the opportunity to present to you the way that Deakin University is going about achieving its sustainability objectives, and in particular, understanding and regulating its energy consumption. My name is Adrian Panow. I'm the Director of Deakin Energy, a university-wide initiative that brings together our researchers and professional units to work on our own energy issues, but also to deliver great value to Victoria, Australia, and internationally. Within the Deakin Energy Initiative are a number of real tangible projects, and the Waurn Ponds Microgrid is key amongst those and the topic of today's presentation. I'll be covering how the microgrid was structured, what its objectives were, and how we're delivering against those. Deakin University is now the 5th or 6th largest university in Australia. It has the issue of growth, and growth itself is both very good for the university's longevity and the courses that we can deliver, but it has obviously an impact on our own carbon footprint. More buildings, more staff, more laboratories, and overall more energy consumption. That growth presents us with an acute challenge in the amount of electricity that we are consuming. When we look at our emissions profile, these are the figures from last year, we see that quite clearly almost 4/5 of our emissions, including scope 1, 2 and 3, are derived from the electricity we consume. Other sources of emissions are obviously less, natural gas following that, and then flights, international travel, wastewater and fuel form up the rest. Fortunately, it is electricity that creates most of those emissions, and it is the form of energy that we are most able to replace, offset, and control within our own university function. The university is a signatory to the UN Sustainability Goals, and we address each of those through the actions that we take. Our overall strategic framework for sustainability includes a commitment to carbon neutrality. At the same time, obviously, energy security, reliability and resilience must be in place so that we can continue to function. And finally, the university has to pay the bills. There must be clarity and certainty around the cost of abatement, whether that be a direct action or an external offset. The 4 pillars of how we address this commitment can be summarized as avoiding, so using less energy, and this will essentially maintain our baseline position. We then need to reduce our consumption. Again, energy efficiency is key, and other forms of how we conduct our business. Then we move to replacing the energy source. Obviously, renewable energy sourced externally and through power purchase agreements and other mechanisms, but also looking at what we can generate behind the meter. In other words, combining both the energy reduction, in effect behind the meter is an energy efficiency measure, but also what we can do to offset grid supplied electricity, which in Victoria has a carbon footprint of approximately 1 tonne of CO2 per megawatt hour. And finally, there will be, after having taken all of those actions, there will be a certain amount of carbon that we simply can't replace or reduce, and we are therefore looking at off-site residual emission reductions. On the pathway to being carbon neutral, we have this summary of the actions that we're taking. Our 2019 carbon emissions were almost 80,000 tonnes from all sources. The first two steps, therefore, are to reduce energy consumption, a lighting efficiency program, different technologies, different timing, integration with building management systems. The building efficiency program overall, improving performance of buildings. The next phase is to replace the energy source with a renewable alternative. Microgrid here is that key action, and other on-campus renewable energy, covering rooftops, covering car parks, looking at alternatives to grid supply. The particular example I will be providing about the Waurn Ponds Microgrid is perhaps unique in that we have the opportunity to do much more behind the meter due to the land available. But other actions are far more familiar to universities and industry and indeed households where we're using roof space or car parks to produce solar in particular. The next phase is to look at beyond our campuses, and we have just entered into a power purchase agreement for green electricity that will supply part of our electricity requirement going forward. The grid itself is decarbonising within Victoria. We're seeing an increase in the amount of wind generation and some solar. And so we are forecasting and making a prediction that overall we will receive benefit from grid supplied electricity. The final part of achieving neutrality will require offsets. We already offset all of our emissions from travel, and finally we will be buying offsets as the last portion of that carbon neutral strategy. The Waurn Ponds Microgrid is a project that when we looked at the opportunity presented by the campus for moving towards a clean and affordable power supply, we had some high-level objectives. Research, key amongst those, the strategic partnerships that we could leverage from creating this piece of infrastructure, a sustainable future for Deakin, and ultimately it all wraps up into a platform to build on. So we looked at the research requirements, what our current capability was, where we would plan to expand, how important were particular types of research, because obviously if you throw it open to the breadth of possible research you could do in energy, it is a boundless opportunity, but one that ultimately restricts what in reality you can deliver. Sustainability, we obviously wanted maximum output from the microgrid. We had to have responsible sourcing. We wanted to use local knowledge to the extent we can, and we wanted to include the ability to expand. Between all of those parameters, we also, of course, had to look at cost. The university is funding this project, and so budget impact, likely additional research income from creating a particular element within the infrastructure. Would we be able to meet our energy demand both overall and instantaneously? How much would it cost to run? How much would it cost to maintain? How quickly would it become obsolescent? All of these parameters were built into the scope of the project before we went to market. And to market we did go just over a year ago and developed the project in several work packages. This is the campus looking at in plan view. West is to the left of that image. As I mentioned, we designed the grid. We spent about $1 million doing the full engineering, design and scoping before we went to market, so that we really understood what we needed and what was to be delivered. The solar farm occupies the most visible portion of the microgrid. 14 hectares of solar, and accompanied by a 1 megawatt, 2 megawatt hour battery, connected to multiple rooftop solar installations. We had to augment the high voltage network in order to connect the grid. A microgrid controller, the actual physical device, ensures that our energy flows are as per design and as required to meet the various objectives of the project. Civil works were not trivial. New roads, fencing, water supply to meet both practical and regulatory requirements. A visualization center, which again I will come to, where we're able to both see the performance of the grid, but also importantly to engage with the community. And finally, to link the system via a dedicated fibre optic link, ensuring that cybersecurity provisions were in place as well. After all, this project is directly connected to the distribution grid, and therefore what happens behind the meter will certainly affect what happens beyond. So this is the overall microgrid project. 7 megawatt ground mount single axis solar farm, 1 megawatt, 2 megawatt hours of storage, 250 kilowatts of rooftop batteries and rooftop solar and small batteries, research, teaching, visualization center, about $20 million in the initial phase, and $10 million of research is already underway. We expect the system to produce about 14 gigawatt hours per year, so just over half of the campus consumption, reduce our carbon footprint by about 12,000 tonnes, and at the same time allow for significant additional growth. A couple of details here where, perhaps unusually for a university, we actually used our own expertise to inform the procurement of the system. Ethical procurement of the battery is the example that I'm using here. We obviously had some objectives of why we needed storage. Capture excess, deal with peak demand or transient peaks. We went procurement details, so the contract had technical performance, warranty, availability, delivery, and ethics. And so our group, some of the people who are in the conference today, supplied this statement, and this is a direct extract from the tender that went out. That the tenderers had to respond with proof that they would ethically and sustainably supply the components that they were bidding in, that they had actually undertaken due diligence, that they were working towards a circular economy where the products would have a start, a use, and multiple endpoints. The battery that we've chosen is a lithium ferrous phosphate chemistry battery to avoid some of the issues around conflict cobalt, and also it technically is far more suitable for a grid application. As part of that process, we conducted direct factory due diligence on BYD in China, 34 pages of due diligence document with hundreds of different points that we went through one by one over a week to ensure that we actually did satisfy ourselves directly that this was in place. We also had to satisfy our local distribution system operator that even though they understood that this was a university project and that we had a research area, their comment was that basically we don't care that it's research, it still has to comply to all of the standards. And so that added an element of reality to the project, but one in hindsight is of enormous value because we can say that this project is actually applicable and replicable beyond the university. I mentioned the Visualization Centre. This is a fundamentally important part of the project, not only to bring our own researchers, but particularly the community for training, for familiarity, and to ensure that there is acceptance and a social license for us to conduct this project, but also to look at expansions into areas such as small-scale wind and potentially hydrogen as well. A few programs from a few slides from actual progress that we're making. These are the small-scale batteries in a 158 kilowatt rooftop system that went in on a incubator building that we have, Manufutures. This has been operational now for about a year, and it will make that building over the full scope of a year energy positive. Other buildings, the cadet building, the engineering building on the left, we had hoped to put 100 kilowatts on this roof, but the roof structure itself would only support a maximum 75. And these are some of the practical considerations that everyone needs to take into account. And a further 39 kilowatts on top of a conference centre that we have on campus, again, for performance, but also for engagement. The solar field itself finally began construction in July last year. These are some of the early pylons going down on a wet, cold July day. And over the space of far less than a year, essentially by November of last year, the panels had been installed and the system is progressively being commissioned. And this was the field as it looked in November last year when it was first complete. The over 20,000 panels, the campus and the city of Geelong in the background. A massive project undertaken by the university, delivered by the university with its partners, Mondo Power, AusNet Services, and dedicated contractors who worked with us, recognising that this was a unique project and that had benefits well beyond just the electricity that it produced. So finally, has it actually achieved what we're hoping to? We'll find that out when it's fully operational, but in the meantime, research is already accelerating. It is a test bed for innovation. We're getting inquiries, our own researchers are coming up with new ideas that they can now use. We're already looking at the opportunity for hydrogen as an adjunct and an alternative to battery storage. We're looking at more sophisticated use, grid services, frequency control from behind the meter. We're commencing a project subject to funding around PV panel recycling. It's a difficult product. It's a laminated glass, but there is a technology developed by Deakin that will enhance that opportunity. And the project has certainly resonated internationally. And we're working with India, with the United Nations ESCAP organisation to use this project as an exemplar of what universities can achieve. So there are many options to meet the objectives. We chose this particular set. I think they're quite close to what we had actually hoped to achieve. Ultimately, it's a project that, had we spent the time to learn absolutely everything and address every risk, it wouldn't have happened. We were bold. We took that risk, obviously within parameters that were within the risk appetite for the university and the University Council. But we made that investment. We've learned a lot along the way, and it's now important that we communicate that knowledge. Both Deakin repeats it on other campuses, but also that we make that available through conferences like this, more broadly, where the possibility and the opportunity is made quite clear. And it is most definitely worth the effort. Thank you.